Liz, I didn't see you there today. Hold on a second. I'm listening to some Grateful Dead with Garrett. Hold on. Gotta enjoy some cold rain and snow with the Grateful Dead. I don't know if you've ever heard this song before, but you can always put it on your Spotify playlist. Fade the music out pro style for you guys. Okay, cool. All right. This is our first psychology lesson via using the webcam and the Google Meets. We had a couple in class. I just want to remind you that if I put notes on the board, I would like them to go into your notebook. Okay, so Garrett's going to try and do a good job following me around so that anything I put on the board goes in your notes. The topic that we're going to focus on today is psychology as a science, right? I mean, we're still in sort of our introduction to psychology part of Unit 1. And psychology, very much so, is a science. In fact, all of these social sciences are science. And so we want to explore that word a little bit and understand what it means and its impact on psychology. Let's start with a non-scientific approach to thinking. Let's start with what psychologists would refer to as, and I just need to finish my heading up here, this would be psychology as a science. Non-scientific thinking would be if we used what psychologists refer to as our intuition. Sorry if I'm a little scribbly up here, but I'm trying my best. I still got to get used to writing on the board again. It's been so long. Right, so we've got intuition. What is intuition? Well, I'll give you some examples of intuition, and then I want you to think to yourself, like, why is intuition not really a great way of thinking? How is intuition sometimes illogical, and it doesn't really make any scientific sense? Let's take this example. I think we've all been here before, especially if you're already a driver. Maybe you 10th graders don't get it, but my seniors definitely will. It's a really cold day in Lake Luzerne. The wind is howling off the river. I got to get gas in my car. I'm almost on empty. And so I roll, I got the heat blasting because it's cold out. It's a cold rain and snow. And I drive up to the gas station and I got to pump gas. And so I get out of my car and I think to myself, like, should I turn off the car to go pump the gas? And my intuition tells me, no. I mean, I know there's signs that says turn off engine, but my intuition tells me I don't need to turn this engine off. It's cold out. I got to keep the heat going. So that way when I get back in, I'm warm. I'm not getting into a cold car again. Right? And probably the same holds true during the summer, right? You don't want the cold to get hot, the car to get hot, and so you leave the air conditioning on and you pump your gas. My intuition tells me that sign says don't do it is baloney. My intuition tells me it's bogus. That is not a scientific thought, because scientifically, here is why that sign exists, right? My intuition says I've never seen a car explode at a gas station. My intuition says it's not going to happen to me. My intuition says, oh, what? Like, I'm going to take the gas and spray it all over the engine and that's going to light the car on fire. I'm not going to do that. But here is the piece of my intuition that is non-scientific. So scientifically, what can actually happen is the fumes from pumping the gas, right, into the car. Those fumes, and you can probably see this on a hot summer day, you see that sort of wave, right? That sort of illusion wave of the fumes coming up out of the nozzle of the gas pump. And that sort of wave of fumes comes up. And what happens during the winter, especially on those cold days, I think we've all been there before, where, I rub my feet on the floor and then I touch metal. What happens during the winter? Oh, I get that little I shocked myself. Just that little spark, right? If I accidentally generate, and I don't even know what's happening, right? I generate an electrostatic charge. I'm pumping gas. The fumes are coming up. I go to lean on the car while I'm pumping, which I'm sure we've all done. I create a tiny electrostatic charge, kablooey. Scientifically, it can happen. My intuition tells me, I've never seen it happen. I don't think that's going to happen. I'm not even really thinking logically about how it could happen if I don't take gas and spray it all over the engine or something. But scientifically, it can happen, and that's why that sign exists. So our intuition, a psychologist would tell us our intuition lies to us a lot. Let's take a look at the professional definition of intuition over here. I'm going to bring it up on the projector, which might just take a moment. That boy running. Right, as that warms up, I'm just going to set up my scientific thinking over here. A more scientific approach to thought is what we're going to term empirical thought. So I'm just going to get that set up on the board, and then we'll take a look at the definition of intuition. All right. So here is our definition of intuition. It's the ability to understand something immediately without the need for conscious reasoning, right? So it's an immediate thought. I immediately think, well, I'm not going to blow up at the gas station today, right? But I'm not really logically and consciously thinking through how I might actually blow up at the gas station if I don't turn my car off while I'm pumping gas, okay? So, these are things that we don't necessarily take into consideration. It's just a gut reaction. I think Gary, even earlier when we started the lesson, said that your intuition is kind of like your gut reaction. Okie doke. So let's refocus over here on the empirical thought. Maybe another example of intuition might be like seat belts on an airplane, right? My intuition tells me that seat belt's not going to do me any good. If we get into we take the idea of a car accident, right? Perhaps this is even a better example than my gas, right? In my head, my intuition is we wear seat belts to save our lives in car accidents. Therefore, I wear a seatbelt on a plane to save my life in a plane accident. Unfortunate news, the seatbelt's not going to save your life in a plane crash, right? But what that seatbelt is really there for, logically, if I were to think more empirically about it, and not just trust my intuition that it's there to save my life in a crash, the seatbelt's really there to keep me from flying up to the ceiling and cracking my skull on the top of the plane if the plane quickly loses elevation, right? So my instinct, my intuition is the seatbelt's there to save my life in a crash. That's the wrong intuition. The seatbelt is actually there to keep me from hitting my head. Scientifically, right? Empirical thought, and I think maybe Mr. Winters and company would love to call this sort of the scientific method of empirical thought. And I think you guys are probably, it's okay if I'm out of the screen for a second, I think. I don't know. I'm going to just walk out of the screen for a second and change the video so that I don't have to put all the notes on the board. You guys can kind of copy this little diagram down here. Here is your basic scientific method. And there's dozens of different variations. You could probably draw it lots of different ways. I landed on this one because I just thought it made sense. So in life, we make some observations. Like I observed that I've never seen anybody blow up at a gas station pumping their car. I observed that seatbelts save those crash test dummies from breaking in half in a car accident. I know that seatbelts are supposed to save my life in a crash, right? And then I observe all this stuff, and I use the information from what I observe and take in through my senses to form a hypothesis. And once I form that hypothesis, which is really like what I would call in social studies a position, I'm going to take a position that such and such is true. So I'm going to take the position that the seatbelt on the plane is going to save my life. Okay, and then we're going to run some experiments. And I'm going to run some experiments. I'm going to find that the seatbelt on the plane, yeah, good luck. Right, that seatbelt on the plane is not really as effective as I analyze the data of what happens to those crash test dummies in plane crashes wearing seatbelts. We find that they get obliterated, and that seatbelt's not going to do much. And so my experiment might sort of reinforce the hypothesis, or if the evidence points otherwise and refutes my hypothesis, maybe I need to revise my hypothesis. And so in doing this experiment, what I might find is that those crash test dummies, upon impact, their lives aren't necessarily saved, but when the plane drops altitude but doesn't actually crash into the ground, that those seatbelts on airplanes actually do protect the crash test dummies during like severe altitude drops. And so my original observation that, my original thought, my intuition that seatbelts save lives in crashes, that doesn't really pan out in the airplane, but I might have to revise my hypothesis and say, you know what, it doesn't save my life in a crash, but scientifically it can save my life in a severe altitude drop where people like fly up to the ceiling. Okay, that's the basic scientific method. And then over here, this is sort of left out. This is the idea of peer review. I know that's a big topic in the news nowadays with like peer review of maybe a safe vaccine for the coronavirus. Are we going to have enough time for peer review? Or are people just going to rush into, this vaccination without giving science enough time to vet the vaccine through peer review? So I know I've been hearing a lot about that communication and peer review in the news lately. So I thought that was an important one in the diagram. A lot of diagrams you look at won't have that sort of peer review piece at the end. I like this one because it does. That's the lesson on sort of the empirical thought process. Psychology is going to follow. It is a science. We're going to follow the same scientific method of empirical thought. Every hypothesis we have about why people behave the way they do has to somehow be proven either through experiments and data collection and peer review by other psychologists. That's it for today's class. Hopefully that wasn't too long or too boring for you. Make sure you get all the notes in your notebook, and I will see you tomorrow.
I'm look at things to the camera for just a second so they can
Sure.
put it all down.
They can probably also go back in the video and just pause it, right?